Last episode 1 said someone has to maintain it, never one person alone, and rarely the person who wrote it. So let us look at that someone, because the shape of that group turns out to be sitting inside the software, whether anybody planned it or not. In 1967, a programmer named Melvin Conway sent Harvard Business Review a paper called "How Do Committees Invent?" They rejected it, on the grounds, in his words, that he had not proved his thesis. Datamation ran it in April 1968. And the unproven thesis was this: any organization that designs a system will produce a design whose structure is a copy of that organization's communication structure. He had watched it happen. 8 people, 2 compilers, 5 put on one and 3 on the other. The first shipped in 5 phases. The second shipped in 3. Brooks cited it in the Mythical Man-Month in 1975, called it Conway's Law, and the name stuck. Notice what the claim is actually about. Not the org chart, the conversations. The paths along which people really talk are the paths along which the software really joins up. The boxes on the chart are a guess, the conversations are the truth. Harvard Business Review wanted proof. It arrived 40 years later, and not from a business school. In 2008, 3 researchers at Microsoft, Nogapon, Murphy and Basili, tested Conway's Law on Windows Vista. 50 million lines of code, across more than 3,000 separate pieces. For each piece they measured the organization behind it, how many engineers had touched it, how many had since left, how far apart they sat in the reporting hierarchy, and how much of the work came from people whose real job was elsewhere. Then they asked which measurements predicted where the bugs would be. Organizational structure beat every code metric they tried, including complexity, churn, coverage and dependencies. The shape of the team predicted the defects better than the shape of the code did. That is problem number 6 of our 7. A serious system does not fit in one head. So building it means holding many minds on one thing, and the cost of that is not a tax on the work, it is the work. Now the servants. Chief programmer teams in 1971, 1 mind designing and the rest in support. Phase gates and sign-offs, coordination by document handoff. Coding standards, so that strangers' code reads in one voice. Design reviews and RFCS pair programming after 1999, alignment by sitting together. Stand-ups, retros, and issue trackers, the state of the work made visible. Then the distributed era, pull requests, code ownership files, API contracts and interface definitions, which is coordination compiled into the interfaces themselves. Team topologies in 2019, which turns the law around and tells you to design the teams you want, then let Conway hand you the architecture. And now, agent orchestration and shared context files. Different servants, one problem, the whole way down. So what does AI do to it? It adds nodes. An agent is a new kind of teammate, and every coordination problem in the textbook comes back wearing new clothes. A context window is communication bandwidth and it is finite, so deciding what to tell the agent and what to leave out is the same editorial judgment as briefing a contractor. 2 agents working the same ground duplicate each other and collide, which is a merge problem you have met before. Brooks's law survives intact, because adding agents to a late project makes it later too, once someone has to specify, review and reconcile all of that output. And a shared context file is exactly what it appears to be, an onboarding document where the new hire is a model. Conway's law does not weaken here, it generalizes. It was never a claim about humans, it was a claim about communication structures, and we have just added a great many new things that communicate. So the skill. Get good at drawing boundaries, at stating precisely what one part must know about another and, more useful still, what it must never need to know. That is the same skill whether you are naming the interface between 2 services, the contract between 2 teams, or the brief you hand an agent. But all of this assumes the group is aligned on something worth building. Teams that build the wrong thing perfectly still fail, and that is the last of the 7. Next episode, the most expensive mistake in software is building the wrong thing well. So who decides what is worth building?